Everybody loves the Raspberry Pi Pico, but unplugging it and replugging it every time you change your code can be a real hassle. But fret not, in this video we're gonna check out how to re-upload your binaries without unplugging your microcontroller. Let's get started. To flash the Raspberry Pi Pico without unplugging it all the time, we make use of the picotool, a tool that is provided by Raspberry Pi itself. And for this, we first have to clone the repository. So we can just search for the picotool GitHub repository. Copy the HTTPS link and clone the repository. I'm gonna clone it into a directory called Pico, as I did in our previous tutorial. We need to make sure to have libusb installed. If we don't already have it installed, we can use the brew package manager to install it. We type brew install libusb, hit return, and let it install. After libusb has been installed, we can start building picotool. So we change into the repository, which looks like that, and we create a new directory called build. Change into that one. Before we can start building, we have to export the Pico SDK environment variable. So I'm gonna do that. And it just points to the checked out Pico SDK repository, which we should already have on our system if we're using the Raspberry Pi Pico. So after that is done, we can fire up CMake to generate our makefiles. Once that has completed, we can run make to build the actual binary. Once the build has finished, we should have a picotool binary in our build directory, which we have here. So we can verify that it actually works by typing in /picotool space help, and it should just print the instruction on how to use it. And here we can already see the functionality we are gonna take advantage of, which is the picotool load command, which takes the file name of one of our binaries and just loads it onto the Raspberry Pi Pico. But before we can use the picotool to flash our board, we have to prepare our project. For this, we switch back to our project. Here we are already there, which is just a Blink project we set up in the last tutorial. So now we have to edit our CMakeLists.txt file and add an additional argument that bundles some libusb functionality with our binary. So to do this, we just add pico _enable standard IO _USB, which, as I said, bundles some USB related code into our binary. An example of the whole CMake file is linked in the video description. After we are done with our change, we can switch back to the build directory and build our project again. After the build is done, we have our UF2 file in our build directory, which we now have to flash onto our Raspberry Pi Pico. And to do that, we have to disconnect it one last time. Hold down the BOOTSEL button, reconnect it, and it should show up as a multimedia device in our file explorer. So we have it here. Let's open it in a new tab. And then we're just gonna pick up our binary and drag it over. As usual, the microcontroller now reboots and disconnects and starts executing our program. Now that that is in place, we can actually try our no hands flashing for the first time. For this, I'm just gonna edit my projects file. And just make the LED blink a little bit faster so we can see a difference. Build it again. And after that, we can fire up the Pico tool, which now resides in the build directory of the picotool repository. And we're now gonna use the load command with the -F option, which means force, which just means that it will force our microcontroller into BOOTSEL mode, even though it is executing a program already. And then all we have to do is point it to our UF2 file and hit enter. It now forces the Pico into BOOTSEL mode and uploads our binary. As we can see, the LED started flashing more rapidly, which means that our binary has been uploaded successfully. This concludes this tutorial for a basic no-hands flashing approach for the Raspberry Pi. Although it is still kinda cumbersome that you have to execute the make and picotool command manually all the time. So if you want to take this further, you can make use of a custom Makefile, for example, and add the picotool to your path and still automate that whole process. I will post a link in the video description to a Makefile of one of my projects where I actually did that. I hope this tutorial has been helpful. If you have any questions or other remarks, please leave a comment and I'll see you the next time.